everyone. Welcome to our .NET Application Modernization webinar with AWS. My name is Beatriz Maeireizo. I'm Global Go-to-Market Strategist at Amazon Web Services, and I will be your host for today. In today's webinar, we will hear from some of our experts in application modernization in AWS, Aditi Sharma, Global Windows Modernization Go-to-Market Strategy Lead. We also have Yuvraj Mehta, Senior Product Manager for EC2 Modernization, Steve Roberts, Senior Developer Advocate for .NET and PowerShell, and Runeet Vashisht, Senior Solutions Architect for Microsoft Platform. And we're really excited to spend the next couple of hours together with concepts, customer stories, and demos on our application modernization. So first, Aditi and Yuvraj will introduce us to Microsoft workloads on AWS. And then Steve and Runeet will dive deeper into how we can modernize our ASP.NET monoliths and demo two of our application modernization tools, AWS Microservice Extractor for .NET and Porting Assistant for .NET. If you have any questions during the presentation, please use the questions section on the right-hand side of the panel on your screen. So without further ado, Yuvraj, the mic is yours.
Thank you, B. Let me just make myself presenter. Great. Thank you, everybody, for joining us today. I'm going to go through some of the high-level concepts with regards to Windows modernization and introduce some of the programs, toolings, and the concepts that you should be aware of as you embark on your journey for Windows modernization. So first, let's cover what exactly is modernization. At a high level, we define modernization as the process journey of progressively transforming your existing application and infrastructure to more higher value cloud native services. Basically taking away the undifferentiated heavy lifting that customers do today to bring them much closer to their businesses and ultimately bring more value to their customers. Here at AWS, we like to think of modernization as a journey that includes enterprise compute, infrastructure, architecture patterns, people, and process as well. And ops, it's an operations and governance paradigm shift, right? And this shift, the main goal of this shift is for maximum resiliency and efficiency, so your business can innovate faster. But when we focus on governance, governance at scale means as you modernize, you need to build automation. This will allow you to scale your organization exponentially and basically, as we call it, take advantage of the cloud economics. There is an upfront investment that you have to do, but it will pay off as you scale your workloads and your people. So let's double click into that. So what are we hearing from customers? Customers ask us, why should they modernize, right? What are the benefits of modernization? How should they modernize their workload, right? And will modernization help them dynamically scale their application? Can they lower their application, operating cost or database TCO cost, right? So these are all the questions that come up. And so we attempt to answer these questions. But with these questions, we also recognize that there's some key challenges that IT organizations are facing. Applications are ultimately the foundation that enable companies to run their business, right? Because of digital transformation, IT decision makers are expecting their application portfolio to grow by 50%, especially in the next 2 years as businesses need new applications. And as all of us have seen and experienced as well the effects of the pandemic over the past 2 years, there has been a rush towards digital transformation, right? You know, I've heard quotes from technology leaders that we have accelerated the 10-year journey to digital transformation into a 2-year journey. Okay, and this journey is continuing, and businesses are evolving their applications, not just to innovate, but to reduce their licensing costs, to have the ability to scale much faster, to deal with technical debt, to remove technical debt, so that you know, there's no friction points as their businesses grow. And also, you know, to ensure that their applications are secure as these applications get moved to the cloud. Okay. In order to address these challenges, right, one of the key what AWS has come up with is the 7 R's, as we like to call them, of modernization. Right. Over here in this webinar, we're going to talk about, you know, mainly the 3 R's of rehost, replatform, rehost, replatform, and refactor. Okay, so let's take a deeper dive into a modernization example with on-prem Windows application. Okay, first, in terms of rehost, is moving the infrastructure from on-premise to a cloud infrastructure. Right? This is often referred to as lift and shift. It is simply migrating an existing application and database to a cloud server instance. There's no need for code changes, and the customer manages the instance configuration, software, images, right? So you have full control over your application, over what type of instance it's running, right? But it's mainly taking the application that's potentially running in your data center or some colo facility and moving it to the cloud. Once you are in a cloud environment, the next transformation that we see customers doing is around replatforming the application and database into a more automated and managed environment. Okay, from an application perspective, that largely means these days is moving from virtual machines to containers. Okay? Containerizing an application is a crucial first step in adopting what ultimately will be a more modern application architecture. Containerizing helps you develop, maintain, and deploy applications much faster and improves portability. Okay? So you can take that application, deploy it on any service within AWS. AWS has tools like App2Container to help automate the process of containerizing legacy applications. On the database side, moving from a self-service model to a managed database service like, let's say, RDS for SQL Server, completely eliminates the need to do activities such as provisioning, patching, and backups. So ultimately freeing up your resources for more value-added activities. The third area of transformation is to move from a commercial software licensing to open source. Oftentimes, these commercial licensing fees can add up, right, to a significant cost of up to 20 to 50% on top of an equivalent open source option. Okay? So refactoring your applications and databases to take advantage of open source can help you lower cost, improve performance, and gain access to the latest innovation. So with that being said, Microsoft modernization specifically is any transformation that removes Windows Server or SQL Server from the architecture of the application and replaces it with AWS open source or cloud native technologies. For apps, as you know, there are a range of options available for you to modernize. I'll refer to these options as modernization pathways. Okay, so there are multiple pathways you can take. So depending upon what the application's use case is, where it's used, and what business purpose it serves, you can pick and choose the pathway that best fits your need. For customers with a large application estate, it's unlikely that each app follows the same modernization pathway. Our strategy at AWS for Microsoft Modernization is grounded in ensuring that we serve our customers no matter the approach that they take. Moving databases to the cloud reduces operational costs and frees up your team to add more value during their day. Rather than spending their time patching, securing, and scaling databases, your team can focus on innovating. Okay. Other benefits for database modernization: resources can be spun up at a click of a button from a console. No capital expenditure and lower operating costs. Flexibility to scale down or switch off resources with serverless architecture, and confidence that the service is reliable with uptime SLAs. And lastly, at the infrastructure level, modernization can also mean moving your Active Directory to a managed offering. With Managed AD in AWS or using Amazon License Manager to simplify your license management. No matter the pathway that you choose for Microsoft Modernization, AWS has you covered. Now, let's go into how what tooling and programs AWS makes available in order to help you with Microsoft Modernization. We view modernization in 3 core phases. The first phase being assess, moving to mobilize, and lastly, to modernize. The assess phase is the beginning of your journey, right? It sets the foundation for a well-planned and well-executed modernization project. After the assess phase, you progress, as I mentioned, to the mobilize phase. This builds the capabilities that you and your organization needs to operate a modernized solution in the cloud. The focus is on developing a landing zone, okay, and building that operational muscle with cloud skills and a strong project plan, and build a compelling business case for modernization. The mobilize phase prepares you for the next phase, which is modernize phase, where you are actually executing large-scale modernization and cloud operations. After completing the mobilize phase, modernization work can proceed rapidly and efficiently. Each successive completed modernization establishes a full-scale cloud operating model for you. There's several AWS tools and services that are available for customers to accelerate the modernization stage as well. So we will discuss these in the next few slides. AWS has helped enterprises in every industry across the globe migrate to the cloud and modernize on AWS, and in doing so have built and honed the tools, services, and partnerships to make your workload renovation, your workload modernization projects successful. In 2015, AWS set up a professional services migration services practice, and then expanded that same practice to a global center of excellence in 2016. We provide a comprehensive set of solutions and guidance to help customers modernize their workloads. We've established a migration services engineering team in 2016 and now have hundreds of engineers building tools to simplify the art of migration and modernization using AWS Migration Hub. And we introduced programs like Migration Acceleration Program, or MAP for short, to accompany best practices and tools with economic incentives for customers and partners. We continually leverage data from projects and from real life customer experiences to draw new insights and pass them on to you. Okay. Microsoft modernization and what programs that we can have. AWS has created a number of offerings to support your modernization journey. Whether you would benefit from expert guidance through partners or ProServe, or you need support jumpstarting your team, right? Sometimes skills are just not easy to find, right? And we definitely recognize that. To putting together a business case, a technical justification, or even a plan of action. Or if you're looking to offset some project cost, we're here to help you. Okay? AWS Professional Services provides a specialized expertise, tailored offering to accelerate migration and modernization of enterprise and ISV platforms off of Microsoft technologies and onto native AWS. Whether you're an SMB customer making decisions to move to the cloud, or whether go to AWS, they want to learn about how from our partners. In addition, partners help SMBs by addressing them in their native language and being geographically close. So who are some of the competency partners? These competency partners, you can reach out to them and find them on our APN network that have successfully modernized their customers' Microsoft workloads and eliminated the Microsoft licensing costs. Okay. Now let's talk about some of the application modernization tooling that we have made available for customers. And I'll start from the left to the right. So we start from the left. The first thing that most customers need is, well, what is the modernization pathway that they should pick for the particular application? And so late last year, we launched actually AWS Migration Hub Strategy Recommendation. So it's a central tool that you can use across all phases of migration and modernization. Okay? This assesses your portfolio of application and provides recommendations on the modernization pathway. So once you know which pathway to pick, then you can go start your modernization journey by either porting the application or containerizing the application. So for example, for porting, we provide porting assistance for .NET, which accelerates your transition from .NET Framework to .NET Core to minimize the manual effort required there. This will basically allow you to run an existing .NET Framework application over to .NET Core so that you can run it on a Linux operating system. Next, AWS also provides AWS App to Container. We recognize that not every application is ready to get refactored and moved to .NET Core. And sometimes customers don't have access to the source code for the application, and that's more specifically true for applications that you have acquired from an ISV vendor or a COTS vendor. And so that's where AWS App to Container comes in, where you can take an existing application running on a Windows or even a Java or even a Linux server and containerize it directly without making any modification to the underlying code or the architecture of the application. The containerization process gives you additional resiliency and portability for that application. Once you have moved that application to a container, you can now plan out the further steps in terms of modernization for that application. And lastly, late last year, we actually announced support for AWS Microservice Extractor for .NET. This reduces the effort considerably to transform your monolithic application into a microservices architecture. In terms of database modernization, we offer considerable amount of tooling for everybody. Okay? The first, starting from the left to the right, we offer AWS Data Migration Service, or DMS for short. It helps you migrate databases to AWS quickly and securely. The source database remains fully operational during the migration, minimizing downtime to applications that rely on that database. The AWS Database Migration Service can migrate your data to and from the most widely used commercial and open source databases. Next up, we have AWS Schema Conversion, or SCT for short. It makes heterogeneous database migrations predictable by automatically converting the source database schema and a majority of the database code objects, including views, stored procedures, and functions, to a format compatible with the target database. Customers can convert from a relational OLTP schema or any supported database data warehouse OLAP schema to Amazon RDS. For example, Amazon Aurora MySQL or Amazon Aurora PostgreSQL, among others. Replatforming Assistant. The Windows to Linux replatforming assistant from Microsoft SQL Server Database Service is a scripting tool. It helps you move existing Microsoft SQL Server workloads from a Windows to a Linux operating system. You can use the replatforming assistant with any Windows Server virtual machine hosted in the cloud or with an on-premise environment running Microsoft SQL Server 2008 or later. Okay. Lastly, we announced to much fanfare Babelfish for Amazon Aurora to run SQL Server applications on PostgreSQL with little to no code changes. This Babelfish allows you to keep your existing queries. It's a translation layer that enables Aurora PostgreSQL to understand Microsoft SQL Server's proprietary T-SQL. You can run T-SQL code side by side with new open source functionality and continue developing with familiar tools. And lastly, it lowers risk of a complete migration faster, saving you months to years of work. Okay. Now, we have Aditi on the call here as part of this webinar, and we want to share what we're seeing in the field from a modernization perspective. Aditi, are you there, Aditi?
Yep, I am. Hi, Yuvraj. Hi, everyone.
Hey, Aditi. So Aditi, can you tell us a little bit what we're seeing in the field from a modernization perspective, and are our customers ready?
Yes, absolutely, Yuvraj. In fact, we're seeing an increasing number of customers that are moving from Windows and SQL and modernizing their applications on open source technologies or AWS cloud native technologies, right? Like you mentioned, many of our customers are at different points in their cloud journey. They have a huge variety of business drivers behind their journey. Like you mentioned, they could be TCO reduction, there could be an increase in innovation velocity and agility that they want. They could even be trying to capture larger market segments and so on, right? So again, they're across a variety of industries and geographies, but all of these customers choose different pathways for modernization, but what they have in common is that they've all achieved their business outcomes by modernizing on AWS. So we're definitely seeing that as a trend in the market.
That is great to hear. So can you tell us of some recent success stories where customers were able to achieve their business objectives via modernization?
Yes, actually, if you move to the next slide, Yuvraj, I can talk about a very recent story with DraftKings where we help them modernize their .NET legacy applications, right? And it's a really good story for a variety of different reasons. It's a story of how modernization on AWS enabled DraftKings to go through a merger and meet their growing customer demand all during a global pandemic. Right. So as you may know, DraftKings, it's an American daily fantasy sports contest and betting operator. And when they merged with SB Tech back in 2020, they really had to kind of think hard, right? They had to integrate their software, their platform, their people, and it required more than just code changes, right? To be able to turn this into an enterprise solution. That's when they decided to dive deep and embark on an intentional plan and a step-by-step approach to upgrade and modernize on AWS.
Great, that is an interesting use case. So tell us more about what modernization pathway did DraftKings adopt?
Yeah, and like you mentioned, Yuvraj, right, there's multiple pathways that the customers can choose depending on what their business objectives are, what their application portfolio looks like. I mean, they could choose database modernization, containerization, refactoring, breaking up monoliths. There's a variety of pathways to choose from, right? So in the case of DraftKings, they very quickly identified their starting point as the core technologies behind their microservices architecture, which was .NET Framework and Service Kit. So they decided very early on that they wanted all of their microservices to be converted into .NET Core. So this, of course, had a lot of technological benefits, like you talked about, Yuvraj, with DevOps efficiency and so on. But it also opened up a lot of other pathways for them, like moving to Linux, containerizing, moving on to Kubernetes. So yeah, they made a very deliberate decision early on to go that route.
And Aditi, tell us about what was the scale of this conversion to .NET Core, and how was DraftKings able to successfully modernize in such a short period of time?
Yeah, so they actually modernized hundreds of their applications, Yuvraj, from .NET Framework to .NET Core on AWS, and they were able to do this very quickly and efficiently because they followed a systematic approach. Like I said, once they had decided early on what approach and pathway they were going to follow, they started with seeking leadership support and buy-in, right? They built a strong business case, and once they had that top-down leadership support, many of the organizations or many of the teams across the organization wanted to know more about modernization benefits. They wanted to know how they could contribute to the project. So it started off on a very positive note. And then they also followed the agile methodology of breaking, large tasks into smaller chunks and managing their backlog. They wanted to keep their scope under control. More important than anything else, though, they actually worked towards creating automation that could do 90% of their work for converting the microservice to .NET Core. So that was really one of the key factors behind how they were able to achieve that level of scale in such a short period of time. So, I mean, it's fairly clear from this example that it's really imperative to build a clear path to modernization with a direction and a philosophy and a well thought out approach.
Wow, this is a great story, Aditi, of how one of our customers identified a business need to modernize, took on the challenge head on, and very quickly were able to achieve their desired business outcomes. So have you encountered any scenarios where the customer would like to modernize, but as we all know, there's significant blockers, right, that prevent them from embarking on their journey?
Oh yes, absolutely, you're right. So actually, it's more often than you think, right? Many of our customers want to modernize, and like you said, many of them don't know where to start or how to start. They may not be able to identify sort of the good candidates for modernization early on, or even if they do, they may just not have the right resources or the right skill set in the cloud native technologies. Sometimes they have everything, but they just don't have the bandwidth, right? They're simply too busy to spare any resources for modernization. That's where our ProServe and our huge competency partner ecosystem comes into play. And I'm happy to dive into a story. I see that you have the slide up with EPOS Now and how our partner Kloya helped them modernize on AWS.
Wow. Okay. So good to hear that we're able to work backwards from our customers, understand their needs, and team up with our partners to help them meet their objectives. So tell us more about the scenarios at EPOS Now and how we work with our partner Kloya to help them modernize.
Yes, so EPOS Now is a leading provider of cloud POS software for retail and hospitality, right? So we have about 30,000 restaurants and retail businesses that use EPOS Now as a point of sale software to run their business every day. They help the organizations manage sales, inventory, reporting, CRM, pretty much the whole spectrum, right? So although EPOS Now has been running Windows-based API environment on AWS for a long time, the company really needed more scalability to meet the increasing customer demand. However, they had a monolithic .NET Framework API that was running on EC2 Windows. So it was really slow to scale and challenging to manage because it wasn't built with modern tools designed for the cloud, right? That's where Kloya stepped in. So Kloya basically worked very closely with the EPOS Now team to move from .NET Framework to .NET Core, from Windows to Linux. At the same time, they actually helped EPOS Now decouple their API into a microservices architecture that now runs on Kubernetes clusters that are managed by Amazon EKS, right? So they deployed AWS Lambda along with Amazon API Gateway to enable easier creation and maintenance of their secure and scalable APIs. So as a result of all of this, EPOS Now can basically roll out software features now in a day instead of what it used to take them earlier, about 3 weeks. So that's a huge efficiency gain right there, right? And in addition, of course, they're able to scale more easily to accommodate international expansion. So all in all, Kloya really worked together and teamed up with EPOS Now to completely revamp their architecture on AWS and really help them realize the benefit of cloud native technologies, truly.
Wow, that sounds like a big win for EPOS Now, Kloya, and AWS.
Yes, indeed, Yuvraj. And I know we have two .NET modernization experts with us today who will do a deeper dive into some of our .NET modernization tooling and the processes. So without further ado, I will hand it over to Steve and Runeet to take it away. Over to you, Steve.
All right, thank you. Hopefully you can see the slide deck at the title page. So hello everyone and welcome to this section of the webinar. We're going to focus on transforming and replatforming your ASP.NET monoliths. My name is Steve Roberts. I'm a developer advocate here at AWS where I specialize in .NET and PowerShell. And I'm joined in this session today by my colleague Runeet. He'll be introducing himself later as he takes us through several demos of transforming and replatforming a typical ASP.NET application. So in today's session, we're going to look at some tools that are freely available from AWS to help you transform your existing ASP.NET monoliths to instead use a microservices architecture. We'll also be looking at how you can potentially replatform parts or even all of those applications and microservices from .NET Framework to take advantage of the more modern cross-platform .NET. Now, we're going to start by discussing how we typically arrive at a monolithic application, which could happen despite best intentions. Then we're going to move on to discuss refactoring, the steps we need to take, and the things we need to consider to help ensure success. To date, that refactoring process has been typically manual, with developers having to move code around and update applications by hand. The Microservice Extractor we'll show you in the session can help with several parts of that process, and Runeet will be taking us through demos of getting started with the tool and performing a refactor, showing you how the tool can help in the efforts. And during those demos, Runeet will also be showing the porting assistant for .NET is another free tool that's available to help with replatforming your applications. And we'll also be discussing why you might want to consider replatforming to cross-platform .NET and the benefits of doing so. Now, both of these tools can be used independently. For example, you could elect to simply replatform your monolith, but otherwise leave it as is. The choice is yours. So let's get started. Now, I've heard it said that no one sets out to build a legacy monolith. However, sometimes starting out to build a monolith might actually be the best approach to getting to an initially minimally viable product or MVP for your customers. And there are also some cases, such as when you start a project with, say, a Visual Studio Project Wizard, where the default application scaffolding steers you towards a monolithic ASP.NET MVC application architecture. Some teams and organizations, might also prefer to just get something out there rather than spending time stuck in analysis paralysis around microservices from the get-go, only to then find that your potential customers have gone elsewhere when you finally release that Uber microservice application. Their plan is, we'll get something out there, revisit the application, and then refactor it accordingly. Now, I'm mentioning all of this so that we start from the premise that all monoliths are not necessarily bad. However, problems can start to rise down the road as those monoliths evolve and grow or sprawl over time. And this can particularly be the case when it comes to applications built to satisfy some internal business need that we thought at the time would be temporary. You know, if we're not careful, we can end up with something that becomes quite unwieldy, slows down development, and it restricts our choices. So let's begin by taking a closer look at the typical life cycle of these applications and how we might end up at a monolith. So most applications probably start out on a simple premise: do one thing well. And in a lot of cases, especially with internal applications, that application is seen as a temporary measure until something better can replace it. You know, we might hear or probably even say to ourselves, let's test the waters and see what engagement we get with customers. Or this will do for the next 6 months until IT write the real version. If customers like the application or it solves the immediate problem, then we'll come back and we'll write it properly. We promise. The thing is, we probably find after the initial release that we need to add more functionality and add it quickly. You know, perhaps the product has become insanely popular and the business just wants to capitalize on that. Sometimes additional functionality gets bolted on because it's similar and management or the dev team decides there's no need for another application. So we might end up adding that new functionality wherever we can make it fit in the shortest time frame we're given. We're satisfying our users and our management, so what could possibly go wrong? The problem, and I've certainly run into this in my former career as a developer, is that all too often these quick additions almost never include the time to go back and refactor what we've done in the future. Or while we're adding the new functionality, we don't take time to pause and take a step back to consider re-architecting in some way, or to determine if what we're doing really is optimal going forward. Now, the first few times we do this, we likely don't notice the storm on the horizon, right? The first couple of iterations to extend the app probably go fairly well, pretty smoothly, and no one's really paying attention. That's certainly what happened for me. That cycle continues to repeat over and over, potentially over several years. Maybe we add some more functionality that needs additional tables, using another database engine that's better suited to the task. And do you remember how this application was only planned to exist for a temporary period until something better came along? You know, we'd made a decision to perform an initial test of market acceptance. If it worked, we promised, quite faithfully, to come back and write it properly. However, as time has marched on, we've actually ended up with an evolved application that seems like it's been held together with duct tape. And without anyone really noticing, you know, we could easily find ourselves a few years in the future needing to do a major revision to an application that wasn't expected to last more than a few months. You know, perhaps some technology that underpins that app is out of support, for example, SQL Server 2008 R2. At that point, there's a good chance one or more of the team who originally created the application are no longer with the company. Or if they're still here, they can't remember the first thing about the original project. You know, perhaps too, they've got more pressing priorities in their new role. That makes it hard, if not impossible, for them to spend time diving into their archives to try and help us guide us on the path forward. So we're faced with the prospect of trying to refactor the app, potentially one that's largely unfamiliar to us, while it's running in production. And it's all unknowingly built on a pile of sand or a house of cards. Choose your metaphor for the state that you're in. So as we reach this stage, why might you consider refactoring your house of cards to adopt microservices? Well, perhaps we've decided that we want all the architectural and flexibility benefits that we would have adopted initially if only we knew the application was going to be around for years instead of a few months. Now, perhaps in reality, this isn't really all that fair to the dev teams, right? Programming paradigms change all the time. It's a given, and it's something that developers are used to. The way we would have designed and built the app, let's say back in 2010, is vastly different to how we build it today, and it will likely be different again 1 year, 5 years, or 10 years from now. The question is, do we have the flexibility in our application and processes to be able to pivot to take advantage of those future technologies? Now, leaving the future aside for a moment, there are real benefits we can realize today by moving our monoliths to a microservices architecture. So with a monolith, if we want to release a patch or perhaps a critical security fix, we have to build and ship the whole application. Doesn't matter how small the change is. And now, depending on the size of the monolith application, those build and test times can be significant. And also consider what happens if the main source code branch contains unrelated changes at that point. Have you finished testing them yet? Do you know if they'll work if they're released to your customers? Or maybe there are changes in that mainline branch that are the foundation of a future enhancement and have had to be merged early to support work elsewhere. You don't intend to make those changes visible to customers yet, So we need more testing to make sure that's the case, that it's not visible, and that the published functionality is still stable. Now, I know some of you are thinking right now, that's poor source code hygiene, and you are absolutely 100% correct. But it happens. It happened in my dev teams when, by accident, a developer accidentally pushed a non-insignificant series of unrelated changes to mainline the day before it emerged we needed to fix something else and fix it urgently. So instead of spending focused time related to the fix we needed, we first had to unpick a large and unrelated set of changes and testing they were removed correctly and nothing else was affected before we could address the real issue. That significantly delayed when we could start the build and test cycle for the patch and the subsequent release, which directly affected customers. Now, besides agility and team interactions, there are also other more cloud-related benefits for microservices. So related to the ability to scale services independently on a horizontal and more resource-efficient way, and reduce those dependencies between teams I've just been talking about. The teams working on microservices can operate independently without needing to coordinate much, if at all. Now, before we can reap the benefit of microservices today or in the future, there are some challenges to overcome. First, we're aware, or at least I hope we are, that over its lifespan, the monolith has grown unwieldy or is becoming so. As I mentioned, builds have likely become quite complex and lengthy with intertwined dependencies. We'll need to discover and unpick those dependencies during the refactoring process. In the code, the functionality and responsibilities are all spread around, and this makes it hard to identify logical groupings of functionality that relate together and we need to consider as a whole. And of course, there's the manual work of actually refactoring the code into a service and then updating the original monolith to use it. Now, in many organizations, the team will quite likely be expected to do all of this while keeping the existing product working. And remember that as we've been working on our applications, we didn't have resources to do refactoring as we progressed, and we possibly have no additional resources to help us now. So we have limited resources, a tangled web of dependencies we need to unweave, and a manual editing process to consider. And that's not an immediate recipe for success. So let's say we've somehow identified some part of our monolith that we want to refactor to a microservice. Let's go ahead and extract it, right? It's just code. So given enough effort, it should be simple, right? Oops. It turns out that trying to extract a microservice from an application and then trying to reroute everything and make sure it still works can actually be quite hard. Because the monolith has grown quite sprawling over time, there's often a lot of spaghetti code tying the application together, not to mention that complex build, test, and release process. And at the end of the day, it's more than likely no one really understands all the interdependencies that have grown and tangled together. Or let's take dependency injection as an example. Sometimes those linkages are hidden, and it isn't until runtime, or even worse, runtime under a specific set of conditions, that you realize something has gone wrong. So let's talk about that traditional refactoring process in more detail. How would we have gone about extracting that single microservice? Well, the process goes a bit like this. First, we identify some functionality that's a candidate to become a microservice. This often starts off by the team taking a low-hanging fruit approach. For example, logging code tends to be common. It can give you that initial bang for your buck to reward your efforts. Or we might choose code based on some imminent need to update it or make a series of bug fixes in the area. Since we're working in that area, we might decide that we may as well refactor there and then. Now, having somehow identified that logical piece, the team starts to dive deeper into the code. Now, the aim here is to group together the classes and the code that would make up the potential microservice. This will include the business logic as well as other supporting classes that are needed. And essentially, the team's needing to figure out where the boundary for the microservice is. And this work, it actually does help us figure out what needs to be extracted, what needs to be copied, etc. But it is a time-consuming process in a large, sprawling application that has lots of interdependencies. Now, there could well be some form of initial refactoring going on at this stage as the team tries to untangle the spaghetti. We might need to make certain copies of certain classes in order to both extract the definition as well as keep the functionality in the original application. Now, we won't update that monolith until our service has been extracted and can be called. So for a time, it's quite likely we're going to have duplicate code. Another example, we might find that some business logic is embedded in the action method of a controller class. All right, if that's the case, we might need to move that into a new or existing class that we can then call from the controller. And all of this may result in a feedback loop, requiring additional iterations to get things ready. We haven't really started the heavy lift yet to extract the microservice, right? All these changes are just trying to smooth the process of what's to come. Eventually, We reach a point where we're ready to extract the code and create the microservice. So the team sets about creating the new project, setting up the API, the implementation, and so on. The end result is a standalone project or a related set of projects, for example, supporting class libraries that can be deployed independently as a single unit. And at this point, the monolith itself is largely unchanged. The microservice is a copy of what's still in the monolith. We have our microservice code, so now we actually take that functionality and we deploy it someplace. Let's say, I don't know, a container running on AWS, for example. The output from this is the code running in some environment and ready for something to make calls to it. So now the team returns to the original application and refactors it so it calls the new microservice. Now this also involves deprecating and removing, if we can, the calls to the original application code that's now present in the microservice. And this part will actually be non-trivial, right? Because at this point you start finding all the weird and wonderful ways that you never realized that your code was getting called. Now, obviously in this process, there's also various test and release cycles before the final code reaches production in your customers. So this could result in multiple feedback cycles while the team irons out any issues with the code and the deployments. And in the end, you're going to swing around and start the process all over again, selecting the next group of functionality based on your code selection criteria. So that's a lot of work to refactor and extract just a single service from a monolith. And this is where a new tool, the AWS Microservice Extractor for .NET, can help. The goal of this tool is to assist developers with the process of extracting functionality from monolithic applications into microservices and updating the remaining monolith to use them. So the Microservice Extractor is part of a suite of what we call assistive tools here at AWS, and we're going to see another assistive tool, the Porting Assistant, later in the session. The Microservice Extractor helps reduce the effort to transform ASP.NET monoliths, so the teams can iterate on that refactoring process and realize the benefits more quickly. Your teams use the tool to identify the candidate code, extract that code, and update the original application. Now, the extractor can help streamline and automate some of the overall process I just talked about, but it can't completely automate the entire process for you. It does help a lot with the undifferentiated heavy lifting though. So in this copy of the workflow that we just discussed, the boxes that have changed color show the areas where the microservice extractor can help. So the areas in blue, they still require you to perform predominantly manual effort. You'll notice the second refactor is actually a combination of two, right? In this case, there's going to be some automated assistance and there's going to be some manual effort in order to make sure everything goes smoothly. For example, the microservice extractor will actually create a new solution for your microservice, generate code in a copy of your original application to route calls away from the original local functionality to the microservice. But often additional effort is required in those refactoring stages. For example, you have to review the refactored code, right? Make sure everything's been taken care of correctly. Automated code replacement can only go so far, but even so, that can be a lot better than doing everything manually. So at this point, I'm going to hand over to Runeet to introduce himself and give us a brief introduction to the microservice extractor, how you can get started, and to cover any prerequisites that you should be aware of. Runeet, take it away.
Thank you, Steve. Let me go ahead and share my screen, and we can go through the steps to get started with Microservice Extractor for .NET. And if I can promote myself as presenter, let me go ahead and do that real quick. All right, cool. Hello, everyone. My name is Runeet Vashisht. I'm one of the solutions architects here at AWS, focused on Microsoft platform on AWS, helping customers developing and modernizing their .NET applications using AWS services. As Steve mentioned, AWS Microservice Extractor for .NET is one of the assistive tools that we released in last reInvent. And as a developer, you can use this tool to visualize your existing ASP.NET application and extract part of that application as independent services. To get started with the tool, you can currently go to the aws.amazon.com/microservice extractor website and download the extractor from here directly. This tool does not require you to work directly with AWS services. You can download and run and install this tool on your workstation as well. Once installed, you can launch the microservice extractor, and this is how the home screen is going to look like. You will see some information at the bottom talking about how it works, the overall flow of the application, the flow of the tool. But to get started with using the microservice extractor for .NET, the first thing you'll have to do is set it up with some pre-required information. So for that, you have to go to the settings tab, and by default, when you will launch Microservice Extractor for the first time, this is the screen that you will see. Now, in the setup screen, few settings that you have to configure before you can start using the tool. First one is the AWS region. That tool will be using to communicate with AWS APIs. Though the tool runs completely on developers' workstations, it still needs to communicate with AWS for authentication and for other API calls. So currently, you have to choose between US East 1 and US West 2. Essentially, it frankly won't matter even if you're not in these regions. If currently you're using AWS and using any other regions, the deployment of your application is completely independent of how you're using this tool. With the AWS region selected, the next thing you have to do is set up a named profile. Named profile is the IAM user profile that will be used to communicate with AWS APIs. Now, if you're new to AWS and new to IAM, IAM is Identity and Access Management Service from AWS, and you can create IAM users, and the users can communicate with AWS services in two ways, either interactively from console, AWS Management Console, by using their username and password. The second way by which users can communicate with AWS is through programmatic access of APIs. And for that, IAM users will have AWS Access Key ID and AWS Secret Access Key. So this is another one of the prerequisites that you need to have an IAM user with correct access key and secret access key. Once this is set up, in my case, I've already created a user profile to save the time. The next step is setting up a working directory. Now, when you will be working with Microservice Extractor for .NET, you will be the Microservice Extractor will be compiling your application and will be refactoring your application on your behalf. And for that, it is going to use a temporary location called as a working directory. So you have to also give a path of the working directory when you set it up for the first time. The last configuration that you have to provide is MS build path to build your application and to identify different parts of the application for visualization and for extraction. Microservice Extractor uses MS Build behind the covers. So you need to have MS Build installed on your machine, and you have to provide the MS Build path here. In my case, I have Visual Studio 2019 installed, and by default, Microservice Extractor automatically picked the path of my MS Build and populated it here. The last one is Microservice Extractor shares telemetry data about success and build failures while you're working with your application code. Though your application code always remains on your developer machine, and the tool also runs on the developer machine, but usage statistics and success and failure metrics is shared with AWS. There's a checkbox to agree to that data usage sharing with AWS, but you can always uncheck and it would still work. Now, once the configuration is configured, is set up, you are now ready to start working with Microservice Extractor for .NET. And again, you'll be directed back to the home screen. And to start with your actual application code, what you need to do is click on Get Started button. And you will see it's giving you an overview of the overall workflow that while working with Microservice Extractor, you are going to go through a couple of different steps. The first one is the onboarding step. This is a step where you are going to point Microservice Extractor to your application source code, to this SLN file of your ASP.NET application, which means to work with Microservice Extractor, you need a copy of local application, local source code of your application. Now, in my case, to show you this demonstration, what I have done is I have a sample application running locally. This application is called as Gadgets Online. It's a very simple e-commerce sort of a demo application where you will see some product listings on the page, then some categories in the left navigation. Users can click on a product and they will get product information, and then they can add those products to the shopping cart, so on and so forth. So nothing very complicated, but at the same time, a little bit similar to what you would see in the real world applications. And if I have to show you the source code of this application, this is an ASP.NET MVC 5 application, which has a couple of controllers. These controllers have their backend functionality into what is called as backend services. So for example, home controller, which shows the bestseller, 6 bestseller products on the page, calls an inventory service. And in the inventory service, I have the application code, which is essentially using entity framework to get list of arbitrary 6 products and returning it back to the controller. And controller is getting list of these products and sending it to the view to generate the UI that we can see on the screen here. Yeah, so simple enough application which can be used for this demonstration, but still something similar to a lot of other applications that you would see in the real world. Now, if I have to start using Microservice Extractor with this application, the process is somewhat similar to this. Once you have configured your application, you are going to click on onboard application, and you have to give a name, whatever you want to call this application. Like I can call Gadgets Online Webinar. Then one of the requirements is, as I mentioned, that you have to point your Microservice Extractor to your application source code. So in my case, my application source code is copied locally. In the current version, we support local copy of the solution or local copy of the source code only. So you have to clone your repo or copy the source code locally on the machine where Microservice Extractor is running. Now, that's pretty much it. That's the only requisite that you need. Additionally, we also support profiling data as well. Profiling data is essentially if you want to perhaps visualize your application, different classes in your application based on the usage metrics. If let's say there are 2 classes, class A and class B, and you also want to capture what is the usage metrics of class A calling class B at the actual runtime when my application was running. So with Microservice Extractor, we ship a profiling DLL, which can be used to instrument your existing application running in IaaS. And what it does is it generates, it captures the class calls going from class A to class B and spit out some telemetry numbers or the profiling numbers. And this can be used in the next stage when you will visualize how class A is dependent on class B. Along with the dependency, we will also show the number of calls which are going from class A to class B. So this is optional, but for this demonstration, I have already captured some data, which I think is in my C drive, call as profiler output. So that's, of course, an optional setting. The next optional setting is currently Microservice Extractor for .NET works with .NET Framework applications. And Steve mentioned that we're also going to talk about another assistive tool called Porting Assistant for .NET. What Porting Assistant for .NET can do is it can help you assess your .NET Framework applications and give you an assessment report of how much of your existing source code is compatible with, for example, .NET 5 or with .NET Core 3.1, depending upon what is your target framework. And what Microservice Extractor can do is if you currently have Porting Assistant for .NET running on the same machine as the Microservice Extractor, then it can do that assessment for you behind the covers as well for the source code that it is assessing for dependency. So if you have that, in my case, I do have Porting Assistant running on this machine, so I'm going to check this box as well. With all these settings in place, I am now ready to onboard my application. So I'm going to click on onboard application. And you would see that as soon as you will onboard your application, the onboarding status will go to in progress. And what's happening right now is copy of the source code is being, your source code is being copied to the working directory. Then Microservice Extractor is going to use MS Build to build your project, build your application solution, and then identify what are the different components or what are different classes currently present in your application and what is the interdependency between those classes. This is going to take a couple of minutes, and once it is done, we're going to come back and go to stage number 2, which is launch visualization, and also go to the next step of refactoring and extraction. Before we do that, I'll hand it back over to Steve to talk a little bit more about what are these different stages and how does Microservice Extractor work on those. Over to you, Steve.
Sorry, Runeet, before you head off the mic, we've got a couple of questions that for you. So sure. Bill asks, is the sample code for this going to be available?
Oh yeah, absolutely. So sample code is available. It is available on AWS samples. When I come back, I will share the URL of the sample code as well. So the answer is
Okay.
yes, it is available.
And his next question, I think, is answered in my next slide. So we'll go straight there. So let me change the presenter back to me, and hopefully you can all see the supported applications slide. So thanks anyway, Runeet. Well, we're going to come back to you shortly with the demos, and we're going to actually take a look at refactoring the code into a microservice. But I want to briefly reiterate some of the prereqs and answer a question that Bill had in the chat, and remind everybody else listening, if you have questions, please put them in the questions, and we'll get to them as we go through the session or at the end. So the microservice extractor. So it can be used on ASP.NET web applications that are written in C#, and those need to use versions 4.7 or 4.8 of the .NET framework. The tool itself doesn't refactor databases, and it doesn't refactor the visual files that are associated with the views in your app. But in the case of those visual files, those would most likely stay in the original application code base anyway. Okay. So our field teams have typically been hearing some common questions from customers who are considering adopting microservice architectures. And that's first like, well, what should I do with my existing databases for the application? How should I handle those? Can a single application database be reused in this new microservices world? Or should they give each microservice its own database? If they adopt separate databases, is it okay to duplicate data? And finally, is it acceptable for one microservice to depend on another? For example, microservice A directly calls microservice B as part of its processing. Now, the database questions are at heart associated with eventual versus strong consistency. So let's take a look at what we mean here. So not every microservice has to know everything about the models within the other microservices at all times, right? Instead, they may simply need to eventually know some of the things. And if you look at the time graph on the slide, the column of green dots demonstrates strong consistency. Eventual consistency is different. That's the staggered orange colored dots. And it means that the data will be consistent eventually. There'll be some time before all of the other systems understand that data. Now, as you talk about the communications that happen between different microservices, this question about acceptable consistency becomes very important, and it has an impact on decisions around the application's database or databases and what you're going to do to handle them. Now, eventual consistency is important for any effort that expects decoupling, and this is because it provides the service the most control over itself. Right? The first bullet, it pretty much tells the main story, right? If strong consistency is required, for example, two microservices need to know the same information at the same time, then that means that either A, one of the microservices has to have enough knowledge about the other so they can go and get that information from it, or B, they both access the same data store. Now, doing that means changes in one microservice, such as to a shared table, could impact another microservice. And this is where a microservice having its own data is the preferred pattern, because it enforces that decoupling. When you start refactoring to microservices, sharing the original application database could be considered to be a pragmatic approach, right? Let's worry about one thing at a time. However, shared databases then means that you generally have to worry about other systems when making a change in one. And that undoes one of the benefits of adopting microservices that we've been talking about. Here's what some dependency relationships typically look like when you have strong consistency requirements in play. As I mentioned earlier on, you might choose to share a database between microservices. That's the upper left example. But now we don't have data isolation, right? And it's tempting for one service to dip into the data for the other. This breaks the isolation and it introduces dependencies that might not be immediately obvious in future. The alternative is to then allow one microservice to ask the other microservice for information, as in the lower right. Right? This also touches on the common question, is it acceptable for one microservice to directly call another? Now, if you take this route, any outage on the supplying service means an outage on the asking service. So in other words, in this diagram, if the purchasing microservice is experiencing downtime and the product microservice calls it, now both services are in trouble. Right? At the end of the day, neither of the approaches shown on this slide are ideal. Now, this is what an eventual consistency approach would look like when we're refactoring an underlying application database, but without introducing dependencies between microservices. So in the example, the product area saves its data. It then posts some subset of that data into a message queue. Now, the other services, they care about messages such as product created, product edited. They're listening for the relevant message. And when the message arrives, they look through it to extract the information they care about, and then they do something with that information. So in this instance, they would save those pieces of information in their own data store, and only the pieces that they care about. This means that the only way the purchasing area is affected by an outage in the product area is when the messages stop arriving, right? And that's okay. The product area is down anyway. There are no messages being sent. So by making this an eventually consistent model, we've eliminated any direct knowledge about a different service and that service's data store, right? Now, yes, some data is being persisted in multiple places, right? But it's almost always a limited subset of the data. And by duplicating data across several microservices isn't considered an incorrect design or anti-pattern. And instead, it provides you the option to translate that data into specific language or terms needed by the additional microservice domain, or the bounding context if you're following domain-driven design principles. And anyway, database storage is cheap, relatively, so the extra data being stored pales in comparison to the advantages that each of these services gets from being free of any other dependencies. Right? It also allows each service to use a database engine that's most suited to its needs. For example, relational SQL versus a key value versus a document versus a time sequence, and so on. So now that we've looked at using eventual consistency as an approach to answering some common questions around databases and microservice dependencies, let's return to examine the workflow involved in refactoring part of an application into a microservice using the extractor. Now, Runeet is going to walk us through a demo of this process very shortly, but here's what we essentially are going to be doing. So we start off by looking at our application and identifying some potential code that could be extracted into a separate service. And you do this through a combination of performing code reviews and by using the code visualization capability built into the tool. Once you've identified some code that you want to extract, you then might have to do some additional prep work before you can actually do the extraction, right? Oftentimes it's helpful to make the code more tool-friendly in order to increase the likelihood of success. Now, this isn't necessarily just updating the candidate code, but also surrounding code might require some updates. The analysis phase may require you to make several iterations between preparing, analyzing, and then reworking some of your code to help the application along. It's to be expected, especially with applications that have been around for a while and they've grown quite sprawling. You may have to untangle some spaghetti before you can move on. At that point, we now want to perform the actual extraction. So as well as deployment of the solution onto AWS, once the service has been extracted, you need to go back and refactor the original application to map calls through to the new service. And the good news is the Microservice Extractor will provide you with a copy of the original project with the necessary changes. And you can either use this as a project in the next iteration or use it as guidance on implementing the changes to the original project. After refactoring the code, you start the cycle all over again and find the next candidate for extraction. So let's go back to Runeet, who's going to walk us through the process we just discussed to extract part of a monolith to a microservice, so you can see the Microservice Extractor in action.
All right, cool. Let me take over the presentation, and by the way, our onboarding is done, so I think we should be able to take it from there. All right, cool. So our application is now showing onboarding status as success, which means now we are ready to go to next step, which is to launch the visualization and hopefully extract one of the services as well. So let's click on our application. So to go to step number 2, I can either select the application and click on launch visualization, or I can simply just click on my application in the applications list here. So let me do it. Let me just click on the application. Now you will see some information, for example, whether the onboarding was successful or not. And a lot of time you would see that if your application was not able to build using MS Build, your onboarding is going to fail. And in that case, you will see some more information about your MS Build logs, etc. One thing I would recommend is if you are going to try Microservice Extractor for .NET, MS Build apparently has a limitation with your application code path. So if your path is really long, I guess 255 alphabets or so, then MS Build will not be able to work. So in my case, I dropped my application source code in C repo, I don't know if you're going to run into that issue or not, but I thought I'll just let you know that make sure that you don't have a really long path for your application. But essentially, everything looks good. Your onboarding status is successful. So I can go to the visualization by clicking on the visualization tab. And as soon as I do that, what you will see is it is going to show nodes and edges which are connecting these parts of my application. And if I can zoom in, essentially each node here denotes one of the classes in my application code, and each edge denotes an interdependency between two classes. For example, here I have selected a class called inventory, which is part of my services namespace. And you can see as soon as I click on inventory, there are a few blue edges and then there are a few orange edges. Each blue edge denotes an incoming dependency. You would see if I just move my graph a little bit on the side, and let me just zoom in as well so that it's visible. You will see that there is a home controller which is calling my inventory class, and hence there is a blue edge showing a dependency. And if I hover over, you will see the call count shows 1, which means that at the time of data collection, when I use the profiling DLL to profile the runtime data, only once home controller call my inventory class. Similarly, if I look at another controller, which is a store controller, another controller which uses inventory class, and at the time of runtime, data collection, there were 25 calls which were made from store controller to the inventory controller. Now, if I look at the orange or the red edges going from inventory node to maybe category class. Now, as the name suggests, category is one of the entity framework models which I'm using in my application. And since I'm using entity framework, I'm also using my DB context, which in this case is in a class called gadgets online entities. But if I hover over on the graph, I could see that there were 31 calls that went from my inventory class to my DB context, so on and so forth. Now, this is stage number 1, where you can visualize how different parts of your applications are interrelated. Now, this application is small enough for me to identify and zoom in and look at the different parts. You might have a really big application where visualizing this may not be convenient. You may see thousands of edges showing up on the page at the same time. That's where you can explore the alternate visualization for grouping. So if I go to the alternate visualization, you would see my classes are now organized by namespaces. So if I just zoom in, you can see that I have a namespace called services, gadgetsonline.services. And within this namespace, I have 3 different services. So even if you have an idea that most of my business logic is in specific namespace, and you want to think that can I extract part of some of the classes in that particular namespace as independent services, you can start with the namespaces view. You will see a similar information even with the namespace view. Here, if I click on inventory class, I see similar graph showing incoming blue edges and showing outgoing orange edges. Now, if your application is large enough that there could be different parts of application which are completely independent from each other, where there is no dependency, and perhaps those are the parts which are good candidate for extraction as independent services, then you can also look at what is called as island view. Now here it's a relatively small application, so there are not many islands, but if you have like completely independent parts of application, like for example here there's a one island which is all about route config, filter config, and bundle config, which are used by the MVC application. Right now, for me, it won't make sense to extract this island because this is the low level code or low level configuration which my application depends upon. But the point here is that you do have multiple ways to visualize your application. One more important thing is that you can always click on back to main view. And if you know that there is a particular class or particular class that you are interested in, you can also search the class by its name here. For example, if I search by inventory, it will automatically pick that inventory class for me. So all these aspects are essentially designed to help you visualize your applications better. Now, in my case, I already have my inventory class separated from my controller. So essentially, if I go back to my source code and look at maybe home controller, in my home controller, I don't have any business logic in my home controller. My all of my business logic is completely decoupled from my home controller's action method. Now, in your case, it may not be the case. You might have a lot of code here. And what Microservice Extractor is going to help you is by visualizing dependency between your components. You might take a step back and have to go back and refactor your code first and then come back here. That's point, right? Where before you even do extraction, you might have to do refactoring of your code before you move further. But assuming that you are all good, you know that your classes are completely independent or decoupled, and you are now ready to go to the next stage of extracting these classes as separate and independent services. Now, the unit of extraction with microservice extractor is called as a group. So you can have a group constituting of one or more classes. And the way you create group is either you select a node, you select your class, right click on the class, and you say, for some reasons, yeah, you right click on your class and say add node to a group. Now, if you have an existing groups, you will see those groups here in the list. In my case, I don't have any existing groups. So I'm going to click on create new, and I'm going to give it a name, inventory service. And at any point in time, I can have more than one group also present in my application. So one way to visually differentiate between groups is by doing some color coding. I, for some reason, end up choosing green color whenever I'm creating a group, but I'm just going to go with it. It seems like it works. So I'm going to give it a color green and click on add. As soon as do that, all the nodes which are in a group will be colored will have the same color. Like that's one way. Another way is you might find it more easier to drag and drop and create groups. Like for example, and this may not be the good example, but let's say if configuration and category, these two classes were logically part of one independent service, I can just drag this node and bring it closer to the other node, and it's going to create a group with that name called as new group. And I can of course right click on the group and look at group details. Oops, for some reasons. Yeah, my mouse is acting up. But essentially, you should be able to uh, the proof that we are doing this demo live is that mouse has decided not to work as expected. Let me switch to a different one. Yep, I think this is better. Yeah. So yeah, of course, on the right hand side, you can see there are group. This is a group information, and once you have your groups created, you are now ready to extract this group as an independent service. And the way you do it is you will right click on your group. Like in my case, I want to extract my inventory group, which essentially is just one node, only one class. And if I want to extract this group as an independent service, what I need to do is right click on this group name and say extract this group as a service. Now, before I go ahead and extract the group, let's quickly go over what's going to happen if I extract this as a group. And by the way, let me just get rid of this group which is hanging in there. Like I can remove existing groups by clicking on remove all nodes and delete the group. If I do that, it's going to prompt me that you currently have two classes in this group. I can click on remove. Of course, my classes are still going to be there, but my group will be gone. Now, if I'm going to create an independent service using the inventory class, what's going to happen is not just this node, the class called inventory that will be extracted, all the dependencies, all the classes that my inventory class depends on will also be extracted. And all of this will be moved into a brand new ASP.NET Web API project. What that means is my entity framework, DB context, my entity framework entities, which inventory class depends on, all of these will be copied over and will be moved into a brand new ASP.NET Web API project so that my inventory class can still compile. That's one. The second thing that's going to happen is all the public classes in my inventory class will be exposed through REST APIs. So there'll be a facade layer that will be created on top of it. There'll be an API controller that will be created, which is going to call my inventory class public method and expose those public methods as REST APIs. Second thing. The third thing that's going to happen is, and it's essentially on the best effort basis, Microservice Extractor will try to modify your existing application. So all the blue arrows, which are currently all the local calls, so my home controller calling the inventory class, Microservice Extractor will try to refactor your existing application and convert those local calls into remote REST API calls. Because Microservice Extractor understands how inventory is getting created as a separate service, so it will try to also convert the local calls into remote calls. Having said that, in my case, I'm doing a very simple local call of inventory class. I'm just newing up the inventory and calling a method called guest bestseller. In your case, you might not be doing this. You might be using some factory method, repository method, or you might be using some dependency injection. Since there are so many variables, it's not guaranteed that this code will be refactored as it is. Hence, after extraction, you would still need to do refactoring. There's no guarantee that both the extracted and the modified monolith will be ready to be used. Expectation is that you will require to refactor your code post extraction as well. But having said that, let's look at the extraction process and let's look at the extracted microservice or extracted service post extraction and how will be my existing application code refactored post extraction. So I'm going to right click on my group and I'm going to click on option called as extract group as service. You will see some information like what is a class which is getting extracted and all the dependencies that this class depends on. For example, different entity framework model entities, as well as some configurations. And of course, I have to give it a name, inventory service. Another thing is, it is possible that you may like to extract your application code as a separate service, but you don't want to modify your existing application. You might be extracting it as an independent services for a purpose where you might like to reuse it in a different application. If that is the case, you can always at the bottom you can tell that do you want your application to be modified to use remote method invocations, or you want to keep it for the local method invocations. The default setting is to use remote method invocation so that Microservice Extractor can refactor your existing monolith and convert those local calls going into inventory class to remote REST API calls. With that selected, you can click on extract and the extract process is going to get started. The extraction is going to take some time. Again, it goes through the same process of compiling your application, making sure that nothing has changed since the last compilation, and then create a new REST API project. And the existing monolith is also refactored. Now, what I've done is before joining this call, this webinar, I already extracted this service, the same inventory service. Let's go at the extracted service and look at the application source code. So not this one. All right. So here is the extracted inventory service. What you would notice here is in the Solution Explorer, you will see that my project structure is quite similar to how it was earlier, but under the services folder, I only have inventory class. And this inventory class has these following public methods. And all these methods are exposed using what is called as inventory controller in this case. And you will see the inventory controller has one-to-one mapping with the action methods with the public methods which are in the inventory class. So for example, there is a method that was generated called as get bestsellers, which returns, which is invocable as a REST API. And internally it news up the inventory and calls the bestseller method on inventory. So essentially it's sort of a facade on top of your inventory class, which was extracted from the rest of the application. Now this is the extracted service. What about my existing application? Well, after extraction, my existing application is also refactored. And what happens in existing application is, here is my existing application, and the first thing that you would notice in existing application is there is an endpoint adapter that has been added. This endpoint adapter is the one which is going to establish connectivity between my application and the REST API that has been extracted as an independent service. I'll come back to the endpoint adapter, but let's look at the invocation refactoring that has method. So I'm going to go to my controller method and I'm going to the home controller. And in the home controller, let me quickly go back to the original code. So again, this is how my code was before refactoring. And in the index method, this code looked something like this: newing up an inventory class and calling a method called bestsellers. But post extraction, this code has been refactored. So in place of calling the local inventory class, it is now newing up an endpoint adapter, or essentially not. It's essentially uh, creating a method called get bestseller on the endpoint adapter. And from there on, the rest of the code works just fine. My endpoint adapter returns my entity model called as products, and these products can be fed to my view, which is going to generate the REST UI. So essentially, post refactoring, the functionality of my application should not change. Having said that, as I said, that it is not guaranteed that all of this code will be refactored by default. You might have to come back and refactor your code. And if you don't want to use endpoint adapter, if you follow a different maybe coding convention to call REST APIs, then you can of course not use this endpoint adapter, refactor the code, and use your own way of calling REST APIs. Coming back in endpoint adapter has a factory class called as endpoint factory, which is, sorry, I didn't mean to click there. Endpoint factory, which has a method called get endpoint adapter. And this is the method which is returning an instance of inventory class. Now, what if, let's say, you end up extracting your inventory class as a separate service, but after extraction, you are doing debugging and maybe troubleshooting, and you realize that there is some issue with my remote APIs. I don't want to use remote API. I want to revert back to the local inventory class. Now, we don't remove your existing classes or existing code. So meaning that post extraction as well, the inventory class is there as it is. And if I want to change this call going from remote REST API to local call, all I have to do is in my endpoint adapter, since it is an adapter here, it also has a web.config. All I have to do is change my routing from remote routing to microservice to from true to false. And once this is false, all the calls will be routed to the local copy of inventory class and not to the remote inventory service. Similarly, if you want to actually call the remote API, then you have to give your API endpoint location here, and adapter will start using your remote APIs. Of course, you have to set it to true in this case. That's a high level overview of what's going to happen once you go through the extraction. And as I mentioned, this is an assistive tool which is going to walk you through the whole process. There are some questions in the chat here that can you access the sample application showed in this demonstration? So the answer is yes. We have created a step-by-step guide which walks you through all the steps which I've showed you, and the link for that guide is that step-by-step guide is already shared in the chat, and we can share it as a follow-up as well. And there was another question that can you deploy your microservices post extraction directly using Microservice Extractor? Or I think somebody has a question that if you have microservices already built, can you deploy them using Microservice Extractor? So the answer is right now we don't support deployment using the Microservice Extractor, but we do have what is called as AWS toolkits for AWS toolkit for different IDEs, meaning that here's a link to our .NET homepage on aws.amazon.com, and you would see that we have different toolkits for IDEs like Visual Studio, Visual Studio Code, Rider IDE. As a matter of fact, if you're interested in setting up CI/CD pipelines, we have a toolkit for Azure DevOps servers and even for TFS as well. So for deployment, it is better you use a toolkit depending upon whether you want to deploy from IDE or you want to CI/CD toolkits, or if you're using a CI/CD pipelines. And if you're interested in knowing how the experience looks like, we have a step-by-step guide for deploying your .NET applications as well. I know it's not related with what we're showing here, but I thought I will just let you know. We are going to include a link for this step-by-step guide for deploying your .NET apps to AWS as well. And this takes an example of Visual Studio, but a lot of these steps are similar for other IDEs or other toolkits as well. With that, I will hand it back over to Steve. Steve, let me know if you're ready.
Oh, yep. Thanks, Runeet. Yeah, there's a couple of other questions in there I think we'll get to towards the end. So about layers of inheritance and interfaces and IOC containers. So I'll let you chew over those while I go
Sure.
through replatforming. So let me switch my display back. And okay, show my screen. Yes, please. All right, so we've touched on replatforming by porting from .NET Framework to .NET, and just briefly mentioned. So before we finish, let's take a brief look at another assistive tool that Runeet mentioned to help with that process. Now, before going further, I want to clarify that when I refer to .NET, I mean the cross-platform versions of .NET, so .NET Core, .NET 5, .NET 6, and so on into the future. .NET Framework version 4.8, which is tied to Windows only. That's the last version of the .NET Framework that will contain new features. In fact, it's already got them. And from now on, .NET Framework apps on Windows will receive critical bug fixes only. So it might make sense for you, as you're going through this process, to also start considering moving your apps onto .NET so that you can take advantage of future feature updates and functionality. But first, why consider replatforming at all? Well, actually, there's quite a few good reasons. As I just mentioned, Microsoft has deprecated the .NET framework, right? So there'll be no new future releases with features and functionality in it. It's bug fixes only at this point, and probably only critical ones at that. And of course, .NET framework is tied to Windows, right? So you might be considering freeing yourself from Windows licensing, so you can take advantage of performance and other benefits of Linux in the cloud. And this includes some fairly major performance benefits that were introduced in .NET 5 for the ARM64 processor architecture. Let's take a closer look at that. So it turns out that once you modernize to .NET 5 or higher, right, you can also get some significant performance improvements and cost lowering for .NET workloads by adopting ARM64 in conjunction with Amazon's custom Graviton 2 processors. ARM64 support has really become a strategic focus for future .NET development, and that's why .NET 5 and onwards include ARM64 specific optimizations that Graviton 2 can take advantage of to boost performance out of the box, and usually without any code changes. And somewhat coincidentally, today AWS is the only major cloud provider that offers an ARM64 processor option. Now, these processors offer up to a 40% better price performance over a comparable current gen x86 instances. And when you start from this lower cost and then factor in the performance benefits, you can drive costs even lower. Some of our customers are finding that it's not uncommon to experience even higher than the stated 40% better price performance. We published a benchmark showing some of these performance gains, and there are some customers such as Raygun seeing great results. They're getting their 30% performance gain for their .NET workloads. So we highly encourage you to think about exploring Graviton 2 for .NET. It's a straightforward transition that can lead to some real savings. So beyond just staying current with .NET releases into the future, there are some real performance and cost benefits to be had by considering replatforming. But as you might expect, porting applications from .NET Framework to .NET can involve significant manual effort, right? You need to spend time identifying dependencies, looking for and resolving usage of incompatible NuGet packages and APIs, estimating the level of effort involved, right, to determine is it really worth it. Now, one question you may have is whether to refactor to microservices first and then replatform, or replatform the whole application and refactor afterwards. And unfortunately, the answer may well be, it depends, right? And to some extent, it could be based on personal preference or experience. If the monolith is still relatively small or young and not grown old and sprawling, then you might want to port first, right, to get the immediate benefits of a newer version of .NET running on Linux in the cloud. Then you can take your time analyzing and refactoring just what you need to go and meet your scalability and team goals. On the other hand, if you have a larger, older monolith, you might get more immediate benefits by refactoring pieces away first, and then considering replatforming each extracted service, as you gain confidence and experience. The really important thing is to not lose sight of the goals, right? Why are you doing this? How much of the application do you need to replatform? What are your team's strengths and weaknesses and experience, and what do they actually want to achieve? Remember at the very start of the session, I said that monoliths are not necessarily bad. Right, so perhaps replatforming a monolith and not refactoring is enough, and that's totally fine if it meets your goals, right? But whichever way you go, the porting assistant for .NET can help with that effort. So let's take a quick look. So the porting assistant, it's another in our suite of assistive tools for .NET, and it's a free and open source tool, and it's available either as a standalone application or as an extension to Visual Studio. It analyzes .NET Framework applications and generates a .NET compatibility assessment. So that gives you some insights on the level of effort that's going to be involved in porting. Right? It illustrates your cross-project dependencies. It's identifying both your compatible and incompatible NuGet packages and incompatible API calls. And then the assessment also suggests the known replacements for incompatible packages and APIs. Now, beyond that assessment, the tool also offers help in updating the projects and the code to make them compatible with .NET. So you're not sitting in an editor necessarily churning through all the changes yourself. It can actually do some of them for you. So overall, it's reducing that manual effort involved in modernizing your applications onto Linux. So now we have an idea of what the porting assistant can do when we come to replatform applications. Let's head back to Runeet, who's going to go and give us a demo.
All right, let me take over. Oops. I'm trying to make myself presenter. Give me 1 second, please. All right, so cool. Thanks, Steve. So as Steve mentioned, just like Microservice Extractor for .NET is an assistive tool to extract part of your application as an independent service, the idea behind Porting Assistant for .NET is to help you assess your application source code and identify how much of your application is currently incompatible with .NET Core or .NET 5. And different parts of application essentially that would be assessed is, of course, any NuGet packages, which is both public and private NuGet packages that your application currently rely on. And then the APIs in your application source code that you currently use. And the way Porting Assistant can help you do the assessment is, again, just like Microservice Extractor for .NET, you can download Porting Assistant for .NET as well from AWS's website. It is available at no additional cost. If you just look up for Porting Assistant for .NET, and we can include this link as well. Once installed locally, just like Microservice Extractor, the very first time when you will launch it, you will have to set it up. A couple of things that you will require. You need to have .NET Core 3.1 installed on the machine where Porting Assistant is going to run. And since it supports .NET Framework versions for which assessment is going to happen, so the .NET Framework version that you will be using for assessment, that also needs to be deployed and running. Once that is set up, then you have to select what is your target framework that you want to use Porting Assistant for. So for your assessments, what will be the target .NET version that you want to assess for? For example, .NET 5.0, which is a long-term supported, not a long-term supported version, but you can go with the .NET 6 version if you want. And then another thing is, just like Microservice Extractor for .NET, for Porting Assistant as well, you need to have a name profile. So I'm not going to go through the same steps again. But once this is set up, and you will be directed back to the home screen, which looks something like this. You will get some information about the flow, and the flow of Porting Assistant is, again, the major step is scanning your source code and then generating an assessment. And you can optionally also use Porting Assistant to port your application from .NET Framework to your target framework. This is assisted porting, meaning that though a lot of boilerplate which comes with .NET Framework applications, such as your web.config and your code in the startup, can be refactored automatically. But for the source code that you have written, Porting Assistant is going to give you recommendations about what code changes you have to make, and it's going to assist you in that process. And porting is an optional step. You may or may not use Porting Assistant for porting your application as such. But let's look at the flow end to end real quick. The way you work with Porting Assistant is you're going to click on Get Started button, and to get started, you have to assess your application, and for that as well, you need to have a copy of source code copied locally on your developer machine. Once you have source code, you can click on Assess a New Solution and point Porting Assistant for .NET to your application source code. So in this case, I have, I think, Knob Commerce version 3.90, which is really older version which I'm using just for demonstrations. Knob Commerce has already been ported to .NET Core, so there's a new version which is already on .NET Core. So it may not be really worth for any developer to port Knob Commerce, but I think it's a good application to demonstrate. So I'm just going to use that one for now, and I'm going to point porting assistant to knobcommerce.solution file. And in my case, I already ported it, but what's going to happen is you're going to click on assess. And once you click on assess, you will be routed back to the home page. And you will see, just like with Microservice Extractor for .NET, the onboarding process means compilation of the source code and understanding dependency of different projects or different classes in your project. With porting assistant, it happens in a similar way, but what happens is porting assistant can work on solutions with multiple projects, and you will see a summary of your assess solutions on the home screen, which will look something like this. Let's look at the summary real quick, and then we can go to the next steps. Now, once I assess the Knob Commerce solution, it tells me that currently this solution has 31 .NET projects, and out of those 31, none of them are ported to .NET 5, which is my target framework in this case. And overall, there were 62 packages, and out of those 62 packages, 44 of those packages are incompatible with .NET 5. Similarly, 421 out of 1442 APIs are currently incompatible. And when porting assistant for .NET performed the assessment of the solution, it built the solution, and in this case, there was no build errors. I'm going to come back to the porting actions and porting in just a second, but let's just stick with the compatibility packages, incompatible APIs, and the ported projects for now. Now, this is a very high level information about the solution. What if I want to look at the information at a little more granular level? So for that, I can select my current solution, which is assist, and click on view details. When I do that, you will see now I can see a little more information at the project level. So there are around 31 projects which are part of the solution. And in this table, I see information about what is the target framework for the existing project, how many other projects are referenced by this project, and then some more information which we saw on the previous screen as well, how many incompatible packages, incompatible APIs, and whether the solution was, whether the project was ported or not ported. Now, when I have list of all these projects in front of me, uh, I may have to choose which project should I go first to port from .NET Framework to .NET Core. There could be multiple ways to do that. For example, I could look at list of incompatible packages and go with the one which has least number of incompatible packages, or I can go with the project which has least incompatible APIs. For example, my ECB Exchange project seems to have least number of incompatible APIs. That's one way. Another way is I can look at project references. With Porting Assistant, we also show a graphical representation of interdependency between the projects. So for example, if I click on knob.data, my knob.data is dependent, is being referenced by at least little more than half a dozen projects here. Similarly, if I look at little more core services which are in the middle of this graph, like knob.core or knob.services, these seem to have a lot more projects depending upon them, which means that if I target these projects, I might be able to achieve maybe higher compatibility, because these two projects comprises of the core functionality. So the majority of my projects depend on these. So this is just one piece of information which could be useful. Second one is at the very high level, what all NuGet packages are currently used. And we saw it earlier that there is a list of 62 NuGet packages, and NuGet packages are referenced all across the projects. So if I want to have a visualization and understanding at the NuGet package level, then the third tab can be very useful for me. For example, if I'm looking at AutoFac, I can see that my AutoFac current version is 4.4.0. It is currently compatible with .NET 5, so there is no code changes required per se. But the version which I'm currently using the Autofac NuGet package version that I'm using. Seems like there is an upper version currently available, so I can potentially upgrade Autofac to 4.5.0. Now I can use this information and perhaps take an action on it when I'm porting the application, or I can choose not to upgrade to the latest version of Autofac. Similarly, let's look at Entity Framework. Entity Framework, we know it probably has pretty major changes between .NET Framework and .NET Core, and hence this package is not compatible at all with .NET Framework version 5. And other piece of information I'm seeing here is that currently it is referenced in at least 8 different projects. And if I want to look at the source code files or the source files where Entity Framework is referenced, I can click on this link, which currently says there are 133 source files where Entity Framework is used. And similarly at the API level, I can either go to source files directly from here or go to APIs directly from here. Or other way I can do is I can click directly on the APIs node at the top and find out what are the incompatible APIs which are currently used throughout my application. Let's say, for example, we have references to iController Execute API, which is part of ASP.NET MVC 5.2.3. Now, it's of course incompatible, but it is referenced in 2 different source files throughout my project. Now, if I click on the source files project, it is going to take me what are those source files, and it will take me to the last tab of the screen as well. And if I click on one of the files here, it will show me the exact line number where this call is being made. And it also tells me that this is an incompatible method invocation. In cases where we can make recommendations, Porting Assistant for .NET will also give you recommendations that you should be using, for example, replace system.web.mvc namespace with Microsoft.ASP.NET Core MVC namespace, right? And what you can do with this information is all of this information can be used to do effort estimation of what needs to be done throughout my project and how much time it is going to take. Now, you can either continue to use Porting Assistant UI and open your source code on the side and make the changes as you go along. Or what you can do is, if I go back, you can export this whole assessment report as well and use that report for your effort estimations. Additionally, since Porting Assistant helps you with assistive porting, you can choose to port this project as well to .NET 5 by clicking on Port Solution. And when you do that, as I mentioned, any of the boilerplate code or any of the code which we can safely refactor for you will be done by Porting Assistant. But all the API calls which are currently flagged, it still will have to be done by the developers depending upon your application code, application logic. But you can use the assessment which is provided by Porting Assistant and then make those changes side by side. Now, what if you don't want to use the tool? What if you want to work with the application directly and use Porting Assistant from within Visual Studio? So that is possible as well. We also support an extension for Visual Studio called as the I don't have the link, okay, but there is an extension also that we ship, which is called as the Porting Assistant for .NET extension for Visual Studio. And once that extension is installed, you can see that extension showing up under the extensions tab as Porting Assistant for .NET. And you can do somewhat similar operations as I just showed you from the tool. For example, you can run full assessment with Porting Assistant, and the assessment's going to take a few seconds, but essentially just the way Porting Assistant bubbled out the findings and the recommendations in the tool UI, you will see findings and recommendations showing up in the error list at the bottom of your current project. And perhaps it's going to take, yeah, I think the assessment just completed. So you can look at the recommendations which are showing under the error list here. For example, here is BA0001, and if I click on this one, oops, nope, I didn't mean to do that. I'll go back to my project and I'm just going to click on double click on this line. Now it's telling me that in this current project, and by the way, this is the extracted service that we extracted using Microservice Extractor for .NET. And since the service was originally .NET Framework, extracted service is also .NET Framework. And if my goal is to port this service to .NET Core, I can use this extension to the porting assistant for .NET and run full assessment. And now I can see the list of all the APIs and all the references which are not compatible with .NET Core. Now I can use this information and I can start making the changes. I can optionally also use this extension to port the project to .NET Core. So I can go to the extensions menu, click on porting assistant for .NET and click on port the solutions to .NET Core with porting assistant. Now it's going to do in-place porting, but once the porting is done, of course, my errors are not going to go away unless I'm going to refactor the code. So what I did is I used these references, of course. I use this information and I already refactored my code before coming on the call. And you would see this is the extracted service, which is currently showing as .NET Framework 5.0. And if I compile this service, it should compile fine now, hopefully. What I did is I used that extension to first port my extracted service from .NET Framework to .NET 5. Then I used all the findings which were generated by porting assistant, all these findings saying that, for example, my road prefix could not be found or HTTP does not exist and all those things. So I went through all of this list and made code changes, refactored my code, and now my extracted service is compatible with .NET 5. Now what that means is I can potentially containerize this extracted service, deploy this service either on a virtual machine, or I can even deploy it on containers powered by Graviton, which Steve also talked about. And through these steps, essentially what I'm going to do is I'm going to start with the Monolith service, which in this case was Gadgets Online, extracted a microservice called as inventory using Microservice Extractor for .NET. And then I ported that extracted service to .NET Core using porting assistant for .NET. Yeah, that's pretty much what I had to show and cover. Steve, want to hand it back over to you for any closing remarks or if anything I have missed.
Okay, thanks, Runeet. So hopefully, let's get my machine showing and we'll wrap up and then we'll take a look at some of these questions. So in the section of the webinar, we looked at how you might end up with a monolith, right, despite your best intentions. And, the monoliths, they're not necessarily bad, but, they can end up restricting your choices and agility. So we looked at the transformation process, right? How do we refactor a monolith into a microservices architecture? Using first the traditional manual process, very heavy manual labor to do the work, and then how the microservice extractor for .NET can help automate some of that process for you. And for those of you that are looking to leave Windows licensing behind or take advantage of performance and other benefits of Linux in the cloud, we looked at replatforming your apps to cross-platform .NET Core, .NET 5 or higher with the porting assistant. So to finish up, we thought we'd leave you with some links to some useful resources. Let me get the next slide up. Here we go. So obviously there's a getting started documentation for both tools, but for the Microservice Extractor, the step-by-step workshop that Runeet mentioned as we went through the demos, and also the sample ASP.NET application that he used are both linked on the slide. And there's also a white paper about implementing microservices on AWS. With that, I'd like to thank you for attending the webinar. We hope you enjoyed it and found it useful. If you want to contact us, feel free to reach out with the contact info on the slide. And with that, we'll take some questions just to finish up in the last few minutes. Runeet, hopefully you're still on your microphone. I have a couple of questions here for you. So starting from the bottom, there's a clarification question. So for the porting assistant, Bill asks, do you need both .NET Core 3.1 and whatever version you want to port to?
Yeah, especially if you're going to refactor your application post extraction, then yes, the version that is that's your target version will be required to be installed on that machine. And Bill also had one more question, which is that what if there are several layers of inheritance and interfaces in your code? How does Microservice Extractor for .NET would work? As long as there is a clear dependency which can be figured at the runtime, the the classes and their dependent objects will also be copied in the extracted code. But if, let's say, you're using IOC containers within your applications, that part currently cannot, well, I won't say it cannot be done, but it's not officially supported. So right now, if you're working with Microservice Extractor for .NET and you're using IOC, you might need to do refactoring either pre or post extractions. But yeah, I think as long as at runtime the dependency graph can be created, all the dependent classes are usually copied whenever an extraction happens. And Microservice Extractor also uses, like, on the best effort basis, it tries to refactor the existing monolith as well. So yeah, I'm sorry, I think I answered a couple of questions in one
No, that's
go.
cool. You answered both questions in one. Awesome.
Yeah.
All right, so I'm not seeing any other questions coming in. So I think with that, we will thank everyone for coming to the webinar. We really appreciate the time that you spent with us. Beatriz, do you have any closing remarks you want to say?
No, just thank everyone for, first of all, our speakers. So to you, Steve and Runeet, thank you so much for this presentation. It was really insightful. And to Aditi and Yuvraj as well. And thank you everyone for joining us today. And thank you for your great questions and participation. We hope to see you in our next webinar soon. Thank you, everyone.
All right, thanks everyone.
Take care.
Yep, thanks everyone.